All right, guys, let me go through this problem right here where I have a rational inequality that I'm asked to solve. Let me show you how we go about solving something like this. So the first thing I'm going to do is I'm going to bring everything to one side so that I have 5 over x minus 3. I'm going to subtract 3 over x plus 1. And that's greater than 0. And on the left-hand side, I will find a common denominator. So that will be the product of my denominators, x minus 3, x plus 1. X minus 3 goes into this, x plus 1 times, x plus 1 times 5 is 5 times x plus 1, minus x plus 1 will go in here, x minus 3 times, x minus 3 times 3. And that's greater than 0. So distributing in my numerator, I get 5x plus 5 minus 3x. Minus 3 times minus 3 is positive 9. And then downstairs, I have x minus 3, x plus 1. Gathering my like terms in my numerator, I have 5x minus 3x is 2x, and 5 plus 9, that's 14. So 2x plus 14 all over x minus 3, x plus 1. So I need to solve this rational inequality. So what I'm going to do is I'm going to identify my asymptotes, my horizontal and my vertical. I'm going to find the x-intercept, and I'm going to find the y-intercept. So my vertical asymptotes, just to start with those, that's my denominator. I let my denominator equal to 0. Well, that would be then x minus 3 is 0, so I have x equals 3. That's one vertical asymptote. Or x plus 1, this is equal to 0, and so x equals negative 1 is another vertical asymptote. My horizontal asymptote, I look at the degree of the numerator and the denominator. I see that the degree of my numerator is 1, 2x to the 1, and the degree of my denominator is 2. I have an x times an x, that's going to give me an x squared. So the degree of the denominator is larger, which means that my horizontal asymptote will be just simply the x-axis, or y equal 0. That is to say, when x gets large in the positive and negative direction, the function will go to 0. My x-intercept, so my x-intercepts, I will let my numerator equal to 0, so 2x plus 14 equal to 0, and solve it. Well, therefore, 2x is equal to negative 14, and x, therefore, is equal to negative 7. And so my x-intercept is negative 7, 0. My y-intercept, sorry, too far. My y-intercept is the value of my function when x is 0. And so I can see that that will be 0 plus 14, so I will have 14 in my numerator, divided by 0 minus 3, which is minus 3, times 0 plus 1, which is 1. So I will have 14 over negative 3. So negative 3 times 1 is negative 3, so 14 over negative 3. And so my y-intercept is going to be 0, negative 14 over 3. I don't particularly care about the value itself. I really just care about whether it's positive or negative, which side of the x-axis is going to be on. And now I can go about sketching a graph of this function. And a sketch is good enough just so I can get a sense of what it might look like. So I have my vertical asymptotes are 3 and negative 1. So actually, first let me just put in, so let's say this here is negative 1, and let's say here is 3. It's just to have an idea. So we'll have here the vertical asymptote there. And I will have here a vertical asymptote right there. Right, so I have two vertical asymptotes. I know that my horizontal asymptote is just going to be the x-axis. It's going to be there. And now I can put in my x and y intercepts. So negative 7, 0. Maybe this is down here. So I'm sorry. Right, that was my x. I only have one. I'm sorry. It's over here. This is negative 7, 0. Is that one there. And the y-intercept, which is 0, negative 14 over 3. So negative 14 over 3 is negative 4 and the 2/3. So maybe that's down here. So this here will be 0, negative 14 over 3. And so I just want to get a sense now of what my graph looks like. I note that my function crosses the x-axis here. And if I look at it again, go back to my original function, I can see that my function will be positive. I have 2x over an x squared. So my function will be positive as x gets large. So my function will be positive out here in this direction. Out here, it'll be positive, so it'll be above the x-axis. And we know it's going to approach the asymptote, and it doesn't cross the x-axis here, so it must go this way. And so I would think my function will look something like so. And then, to see what the function will do on the other side of my asymptote, I will look at the multiplicity on x minus 3. So x minus 3, which is the factor that gave rise to that asymptote, has a multiplicity of 1. And so I know that the other side of this asymptote is going to come up here. It's going to go in the other direction. So if this goes positive on this side, it must go negative on this side. I know that my function does not cross the x-axis here. And so what it must do is it must come down. I don't exactly know where. It crosses there, of course, and it goes here and here. And so all I care about is that between the value of negative 1 and 3, my function is going to be negative. It's going to be negative right here. Then finally, I know that the multiplicity on my factor of x plus 1 is 1. And my multiplicity here is 1, my multiplicity here is 1. So my multiplicity on this factor, which gives rise to my x equals negative 1 asymptote, is 1, which means that my function on the other side of this asymptote, on the other side, if it's going to negative infinity here, it must go to positive infinity here. So it comes something like so. And then we know it crosses here, and then it goes off to 0 right there. And so that is roughly what my function will do. Again, bear in mind with this inequality, we just really care about the signs of the function. Where is it positive and where is it negative? And so I remind myself by looking at the function that I care about where this function is greater than 0. So where is it positive? Well, it's going to be positive. Take out my highlighter. Here is the function positive, here, here, and all the way up there. There's the function positive. Between these two, it is negative. And then here again, it is positive, positive, and it remains positive all the way out there. And so it remains positive out to, as x goes off to infinity, my function remains positive. It approaches this asymptote, but never reaches it. And so the answer then is that x is positive between minus 7, greater than minus 7, and less than negative 1. So x greater than minus 7 and x less than minus 1. And x greater than 3. So here's 3, and so x greater than 3. Or x greater than 3. I'll write this in set notation that my function is positive from minus 7 to minus 1, union 3 to infinity. So from minus 7 to minus 1 is my function positive, and from 3 to infinity. Obviously, at exactly minus 1, my function is undefined because my denominator, go back up here, my denominator would be 0 at a value of x of minus 1. That's why I have that asymptote there. And so that is the answer. Minus 7 to minus 1, and from 3 to infinity. Thanks.